Can my robot drive between two cities by itself, controlled by LLM? Imagine LLM agent able to make own travel decisions, avoid obstacles, ride through fields, forests, ice and snow, and finally reach its destination. Or not.
Very good. Oh. Too fast, baby, too fast.
In previous video we made LLM to drive another robot, XL robot, but only on the distances of few meters, not 1.5 kilometers. My name is Grigory, and in that video I will show you entire story how I created an AI agent controlling a robot on long distance travel. How far robot can go by itself? Can we code robot compas to work better than producer does? And will it able to find its destination after night falls? Welcome. Our robot we test today is the Earth Rover Mini Plus. Neat for wheels machine you can control remotely over the internet. It has two cameras, GPS-RTK and slot for a SIM card for internet connection. But obviously remote control is not what we want. I opened that if we click here, we find a panel with AI agent. After setting up OpenAI API key, we can provide the text task here, and the AI agent inside of the robot tries to execute it. So that way I provide here a task to go to the nearest city, and after a little ride, our robot successfully did it. Mission accomplished.
Mission accomplished. Good work, Marines.
And this is all from my side. Thank you for watching the video. Leave a like if you found the video interesting and content rich, and subscribe for more of similar content. Ciao! Okay, I'm joking. Default robot agent is not able to go to the nearest city or even perform much simpler tasks. I asked it to locate car in the yard, but instead it started to doing some random movements forward, backward. And that's all. There's few problems I found with default agent. Its inputs are just forward and backward cameras. It has no idea where it's located on the map and which direction it's facing. It has also no idea where its destination located. And additionally, default agent is driven by OpenAI model under the hood, but according to our experience, Gemini models work much better for robotic applications for now. I mean, there are single models on the market that work somehow for the robotic applications. I state that the given task is just impossible to perform using default agent. Luckily, producer provides the SDK for an Earth Rover, through which we can control robots move programmatically. It seems we can create our own AI agent with it.
I first tried to run SDK to control my bot, and through that it seems I can run already simple control commands. For example, by sending simple request, I can enable his lamps. Wow. What if I ask him to move his wheels? Let's go full speed forward. Oops.
In my previous videos, we created a RoboCrew framework, allowing us simply, in few lines of code, create an LLM agent to control a robot. Currently, it supports only XL robot, but my idea here is to extend it to support Earth Rover 2. First thing we need to do is to make our agent to send commands to control the robot over SDK. So we embed a request to the SDK inside of the tool, then request will be sent when the tool will be called by LLM. I created tools to move robot for specific distance, which is controlled just by number of requests sent to our SDK. Also, I created a tool to tune our robot, for example, by 90 degrees. As an input, our robot receives images from the forward and back cameras and the map view. The LLM run in our agent is Gemini Flash, the same that runs an XL robot.
And let's run for the first time our agent for the Earth Rover. And obviously it does not work.
Same as in case of XL robot, we added image augmentation to the camera view of the robot. By default, the Earth Rover SDK returns map showing the robot position, but not a direction the robot faces. Using the robot compass data, I'm augmenting the map as well, adding the arrow showing the robot orientation, and another arrow that shows the robot direction to his destination point, just like in computer game.
Okay, he proceeding. Another 3 meters forward. Just not 3 meters, but well, at least he moving. He progressing. Oh well. And very big problem here also that our robot can turn over very fast. So probably when he will go somewhere far away by itself, a lot of kilometers, he will just turn over many times. And I don't know what to do to not make him stop after few meters on the first turn over. So one of the things I'm doing to improve his navigation abilities is to improving the prompt of our rover. What I'm doing here is actually the same thing I did with my XL robot project, where I introduced the precise navigation mode to improve the, well, preciseness of navigation of our robot between the obstacles. We did it in the XL robot project in one of my previous videos, you can see it here. Okay, I improved my prompt together with AI, but after all I need to check it by myself. And now also I want to improve the image augmentation of our camera image to add that meter marks on the front of him.
I improved his prompt, explain the robot not to go into the high obstacles.
Another day, another test on improved prompt. It's quite cold weather today, not really pleasant conditions. He's just going forward. The terrain is much more pleasant, so that's why he haven't turned over yet. I'm interested when he will decide to turn. Okay, I haven't filmed it, but he just turned the perfect direction. Oh, he turned again. Oh, that's interesting. Maybe he trying to make his road around that house. I really prefer to make the experiment in summer, but well, guys, everything for you. Because the direction I set up for him is that direction. But he goes somewhere there, maybe trying to go around the building. I really wish to know his thoughts. So he just made a circle around, and there, and there. Is he going to go into that icy water? I don't understand his logic. Instead of going into the shown direction he placed on the map with the circle where to go, instead of going into the direction he just goes around, makes a circle in a single place. Why? I don't know.
My theory is this happened because LM cannot really understand from the arrow rotation on the map where it's really facing. Maybe arrow is too small, or LM just not understands what does arrow mean. I need to show my robot his orientation a stupid, simple way. Instead of rotating arrow on the map, I decided to rotate entire map. So now arrow always faces top, but map turns. Also, I added right-left signs to the map. That way robot will understand easier which direction it needs to turn in order to face his destination. And made few code and prompt improvements. But will it really help our robot to navigate better? We will see tomorrow. This time, I want the robot to go concrete particular distance, 200 meters through the park.
So I set up the target destination of our robot for that chimney you can see on front of you. He trying to get aligned with that chimney. You can see that? He aligned with it and going forward. Amazing.
And my robot goes forward to his destination, completely autonomously.
Okay. He's rotating to not go into the tree.
50 meters done. The robot never turned over so far. For some reason, it decided to go wrong direction. It's too much left.
Okay. He gone deep into the leaves.
100 meters, half of the park.
But it's not good direction. You actually need to go that way, not that.
Leaves again. But this time the robot gone through it. 150 meters, close to the finish. Oops, there's an obstacle happen in the form of the children. I have not expected such kind of obstacle.
He again digged into the leaves. I'm curious how can he go out of it. Wow.
and robot achieved fence on the path. It did 200 meters by itself. We have a lucky day today.
So my robot just made his way in the good direction and through all the obstacles, sometimes with my help when I just needed to turn him back when he turned over, but mostly he did it by itself, which is a real good progress.
But the biggest problem is that it took for a robot more than 1 hour. It just thinks too long. Our rover, as you can see now, a little overshoot. It's the intended from my side. Because when he overshoot in the flat surface, in the rough terrain, it will be just okay.
And another important thing I'm doing now is I'm going deeply in the code and measuring all the time of every important function to optimize the time of the robot thinking, just to make him think and process information faster. Every millisecond counts.
I did many big environment improvements to make robot react faster and understand input data better. Yesterday we managed to did a 200 meters in the park, but today I want to go even further, to go few hundred meters through the fields in the off-road conditions. Will our newest improvements allow me to do it? And the robot started its way, but suddenly moved in the completely wrong direction. And then, yet another direction, wrong again. Robot been rotating in place for half an hour, doing zero progress towards its target. When I checked the logs, I understood that robot magnetic orientation, for some reason, constantly changes in the random directions. Its compass became useless. What's happened with it?
I think in that place is just something wrong with the magnetic field, and that's why our robot has wrong heading in his map and go in the bad direction.
I had problems because of the robot is just too cautious in the rough terrain, trying to avoid obstacles that in fact are everywhere. But I was all completely wrong.
Oh, he know how to turn over back. Very good.
The root of the problem I found after many tests is the orientation parameter returned by a robot, which I used to get, well, compass orientation of our robot. That parameter returns correct magnetic orientation of our robot until the robot stands on the flat terrain.
Every time I'm rotating the robot like this, now this, now this. He thought he facing different direction, but in fact he constantly facing same one.
It seems producer made the robot to orientate on the flat and pleasant city terrain and totally unprepared for off-road conditions. It just can't get its orientation when it met any terrain and flatness, and without knowing robot's orientation, we cannot navigate it to its target. But I'm not going to give up so fast. Luckily, SDK also outputs low level data from the robot sensors: magnetometer, gyroscope and accelerometer, everyone in the 3-dimension vector. I'm trying to write a function that calculates an orientation of the robot based on the magnetometer data. That's always not so easy as I assumed. To calculate the true magnetic declination of our robot, we need actually analyze his data he provides on his logs. From that data we need to not only take magnetic directions, which probably the original code of that doing, but also we need to take into account the accelerations which is there to see where the Earth's acceleration is pointing, to be able on to base on it to correct the robot position in the space, and on the base of it to calculate true magnetic declination of our robot. By fusing data from these sensors, I should get true compass acceleration independent value. I end up with exactly same value as our SDK output, but I still not give up. After some research, I'm starting to realize that issue with the manufacturer's data wasn't due ignoring rover's orientation related to the Earth. They took it into account. The problem is they didn't account for the magnetic biases introduced by the Earth rover itself. Every object that contains some metal has its own magnetic field. Rover has a lot of such elements inside, but most impactful are electric engines. Engines are located relatively close to our compass. Their field interferes with the Earth's magnetic field and introduces own biases into the orientation calculation. But how can I find the biases values? I web-coded a script that does it. We need to calibrate the rover by rotating it around all axes. Then we know the biases in the all directions. You remember that 8 move your phone asking you to do in order to calibrate its compass? That's exactly the same procedure. Finding of device magnetic deviation.
And I finally did it! You can see that now my bearing, which is in dead lines, is almost constant when I rotate the robot. This is my bearing and this is the original producer bearing. When I rotate robot around his axis, that producer bearing is changing, by my bearing it stays almost constant, which is amazing. I calculated it better than the producer did.
And to make compass in the rover work even more precise, I include Earth's magnetic declination correction. Earth's magnetic poles are shifted from the geographic ones. Based on the rover geographic position, script calculates declination error and subtracts it from the rover's compass measurement. Now robot's compass shows absolute heading, independent from the robot's tilt or magnetic declination. I just did something that works much more better than producer's original code. Already starting to be tired of trying the robot in the field over and over again and constantly meeting some bugs. But I will not give up until my robot will do the road from one city to another.
Okay, it's 12:30 of the time now. You can see here the last building of the city from where we start, and it will be big, very big adventure. Yes, keep going forward. Its tires are full of mud. Okay, he trying to turn, but without success. Robot does not turn over, but just stuck and can't proceed. I need to help him a little bit.
That concrete blocks are very dangerous for our robot. It constantly stuck in it. It's a big risk of turning over here.
Robot, no! Not go there! Not go there! No! No!
Robot constantly turns over when it goes into the trench on the side of the road. It's a really hard terrain for it.
It almost did it. Did hold that way through the beton plates without my help. I'm proud of him. It's hard terrain for him, but a robot doing what it can to overcome all the obstacles.
Our robot made his road through field and concrete blocks with little turning over only. But there's even more tough obstacles wait for it further.
Wow! Wow! So basically, when our robot is out of different obstacles, like very steep obstacles, I mean, he performing quite good. The robot is not going to turn over and it can slowly but steady go to its target.
At all producer demos, they use that robots to go only in the cities, on flat terrain. No one expected that robot to be up for such off-road challenge. I mentioned that when the robot tips over to his back side, it still can recover itself by moving backward. So I prompted it to move backward when it sees sky on its camera. That way, the robot became more reliable and autonomous. The forest is a terrain with a lot of bushes, leaves and grass on which our robot constantly hangs out.
Now it's 2:30, it's already 2 hours how we with the robot trying to work together. Our robot definitely cannot go through the forest roads. That's why I decided to change his road and to ask him now to go out of the forest through that road and go into the fields.
and robot goes through the beautiful snow field. Better than I expected. Just see his tire traces on the virgin snow here. After exiting the snow, robot enters field with many trenches in it. That trench spread 2 fields seems to be impossible obstacle to pass. The biggest problem I mentioned during this run is that robot can turn in the rough terrain. Because of it, robot often goes straight into the obstacles and it can't avoid them or just go somewhere totally bad direction and can't turn back into the good one. And I know the reason of the problem. The robot can't turn now in rough terrain because it tries to turn in place. Such turns have not enough power to resist mud. However, it can go forward or backward, as such moves are just much more powerful. Solution: I made robot to turn when it goes forward to have the power for turning. Also, to make our robot to be able to avoid the obstacles, I added the waypoint feature. So now our robot is not just going to one single destination, but have few waypoints in the way and going that waypoints one by one. And that way our robot will not go just straight forward to final destination, but can have different road modifications and have no straight but curvy road to the pass. More optimal road. You may be wondering if I tried to run Earth Rover with any open source model. Yes, I did. I tried few models, for example Gemini 3 or Quen 3 VL. All of them respond faster, more stable, and does not generate huge bills on API. But problem was, I didn't find any model that generates something else than just random noise and nonsense decisions. It seems that open source models, at least that ones I tried, just do not understand physics. That experiment stretched definitely for much longer than I thought it will take initially. Every day I improved the robot algorithm and repair bugs, but then I found next ones. The problem is that the time for the project is coming to the end. In 2 days, I need to travel to other city to start with my team work sprint on the XL robot project. So tomorrow is the last day I can run the Earth Rover. It's only single chance left. All or nothing. But before our final try, let's sum up the way we passed so far. At the beginning, we connected the Earth Rover SDK to be able to control the robot by LLM agent. We equipped agent with movement tools and provided it with camera feed input, augmented by angle markers and map on which we placed the arrow showing robot orientation and bearing to the target. In the series of the next experiments, we solved many small and big problems, improved his Mac augmentation to understand his destination direction better, teach it to record itself when it turned over, and made it turn reliably on muddy terrain. Also, we got low level into sensor data and made it reliably get its compass bearing even when robot is tilted. All the job I done is open source. You can find code in the description and test the code on your Earth Rover. And also I will really appreciate if you support my channel by leaving a like under the video and subscribing it. We're starting from the Toshek city, the one with a beautiful ancient castle, and want to go to our target, the city of Sarno, which is located 1.5 kilometers from here. It's morning now, little later than 9 o'clock. This is the city we're starting from. This is the robot. It's very muddy and steep terrain. It's hard for robot to go through it. First terrain complication, the trucks left after some tractor. It seems the robot goes into getting trap of some old tractor truck and just can't go out of the truck. It goes with the truck. Truck is going into good direction. Robot exited the trucks and goes up to the hill with steepy and muddy surface. Oh, seems the robot stuck in the mud? No, it managed to quit it. Our robot is very near to the edge of the field. It's a very dangerous situation. I don't want him to go there and to turn over of that high grass or just stuck in it. Our robot goes to his mind, retreated, changes position and goes again. Oh, oh, that was dangerous, but it did it. Now robot enters the road. While the road itself is very pleasant ground to go for a robot, it's flat and dry. The biggest challenge with the roads, as you know from the previous experiments, are sides of the road, with cliffs, trenches and high grass. It's enough our robot will go 2 meters right or left and will have a big chance to turn over. The robot, the fields we need to go through. It's already plus minus 200 meters and for now our robot doesn't turn over any time. Let's keep that fingers crossed to stay it as it is. At that moment robot decided to exit the road and go into the field. Very rough field. And here robot turns over and can't do anything. It just rotates wheels and can't stand up. Oh, you see that? Wow, he did it! I'm already going to help him, but he did it finally after trying to turn over 10 times. Finally it reverted from turning over by itself. For now I haven't helped him any time. So all that road from the almost buildings from the beginning of the fields to there, robot did alone. My robot travels alone. Robot dig itself into the mud, literally. 250 meters. The first time I need to recover the robot manually. It's also wet ground, but we'll see. It's little rain started. And my robot still going, but I'm afraid about the train. If it will be more harder, I will need to take the robot off the field and pause the experiment. Weather conditions became harder and harder. Rains made ground wet, so even when I rescue robot, it stops few meters later. Yeah, for now it's going. For now. Because of all the trains, that fields are just too muddy to make that robot pass. I don't know what to do. Robot just cannot move in such conditions. Increasing engine speed, cleaning wheels, nothing helped. In such situation, I had no choice. The robot cannot move forward because the ground is just too wet. I will leave him here for an hour and return later after, I hope, the ground will be a little drier. I hope it will be drier. We will see. I decided to pause experiment, leave a robot in the place it stopped and eat the lunch in the city. If ground not get drier after a turn, I need to admit a failure of my experiment. It's moving forward! When robot became too dirty, it can't move. I just need to wash it. I needed to clean the robot and help it to recover from the mud a few times. Well, after my return, sun little dried the ground, but still far from being perfect, especially on that particular rough field robot was. I needed to help robot to avoid that muddy field and moved it a few meters to a field nearby. That seems more drier, at least on beginning. On all that mud, robot was able to go forward or backward, but wasn't able to rotate. To solve it, I'm increased the speed of moving forward during rotation, and now robot can somehow turn in that muddy field. The distance we did so far. Field, road, another field, but there are still more adventures to come. and the robot goes forward. Slow but steady. Sometimes it's stuck or turned over, but it's able to help itself. Sometimes not. That I rescue it manually, minimizing external help as much as possible. Field we're running now is relatively dry and flat, but it has another problem.
The robot stuck because of the such root under him. Let's evacuate robot from that field by setting the destination waypoints to the another nearby field here, which has no so much corn and wet ground, so that field should be much more safer for robot to navigate. 500 meters progress done by our robot so far. My robot drives alone. Again.
Hopefully, that green field does not make much trouble for a robot. He steadily proceeds to his destination. The time now is the 16 o'clock, so excluding 2 hours lunch pause, robot drives already for 5 hours. We did already 800 meters, the halfway. I'm starting worrying about the battery state. Producer promises that in flat terrain, battery will be enough for exactly 5 hours ride. Luckily, our ride is full of pauses as LMs need to think, so battery consumption theoretically should be lower than during the continuous ride. But still, I don't know the battery state now and don't know when it's going to die. Robot stuck again on the route.
Go, 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 go. Go, go, go. Go, go, go. Oh! It managed to get free. At least for a while.
Robot constantly stacks and turns over on that corn routes. The single hope for him, he will go out of that cornfield as soon as possible. Will it able to do that distance by itself? We already did first 1000 meters. It's only 500 left.
Very good. Oh. Too fast, baby, too fast.
My honest thought I came by doing that project is that LLMs are not the best solution for steering a robot directly. It produces unoptimal moves when robot turns to the bad direction and also burns a lot of tokens. In my opinion, better architecture will be when LLM just does high-level decisions like I need to exit that field in that particular place, while some basic non-LLM algorithms should do a low-level control of robot movements. Maybe it's an idea for another video.
Robot exited finally that cornfield. Finally, robot on the freedom. Whoa! Robot, where you go? Don't go there. Go to crossroads. Don't go there.
The robot needs to go to the other side of the field road, and the single way to cross that road is to do it on crossroads, where field slightly changes into the road. If robot will try to force the road a little bit lefter, it meets steep embankment, impossible to pass. Where it goes? Oh no, robot goes directly into embankment. He can't climb here, he's just too small. But see what happens when robot can't climb. It tries to go around it. It moves along embankment, trying to find next exit. I can easily take the robot on the top of embankment manually, but I'm not going to do cheating. The idea is to make robot travel alone, so I reduce my help to the minimum. Here robot, walk along the hill. We did more than kilometer already, and there's 400 meters left to the border of the destination city.
Something happened with my robot and just stand here and does not receive any movement command from the server. That's really strange. It seems I have some API problem. Maybe I did just too much requests today. Interesting. There's been definitely too much requests.
I did so many requests today, so I've been just rate limited by Gemini. Robot cannot move forward. So I changed this from direct Gemini calls to open router, leaving the same Gemini 3 Flash model.
And robot, you can see, goes, and it will try to reach that crossroad.
Robot moved again and get close to the next crossroad. He's another chance to cross a road and get closer to the destination city. Time is 5 p.m. already. With every minute it becomes darker, colder, and the ground becomes more wet. And there's still 3,500 meters to do.
The target city is already very close here. We can see the first houses of it, which we want to achieve.
Robot can see the world around, worse with every minute. Probably because of it, it makes worse navigation decisions, goes from direction, goes into the obstacles. Soon, robot will be completely blind. So it's time to enable lamps. Robot finally enters the road and makes beautiful night ride through it. 200 meters. Last 200 meters. I never did so long night ride with that robot. Risky car, but robot moves down without turning over.
There's water here. Quite dangerous for the robot. Oh well. It goes just near the water, just near it. Traveling with robot at night. Amazing experience.
Robot goes out of the road into the last field that divides it from the city.
There's already fires of the city. We just need to reach that lamps and we will be at home. It's very close to the city, but it's last straight line.
But despite of the cold, I'm glad I stayed in the field till that hour. You can see how beautiful robot's night ride looks like. But here, I get rate limited by open router too. Robot stops. I have no other account on open router or Gemini. I needed to call my friend to ask him about his API key. Robot moved. In the darkness, it will be much harder for me to recover it. 100 meters! Almost there! For now, robot didn't turn over any time in the darkness. 50 meters?
So it seems I lost my rover in the darkness and I'm going to the field to find it. I cannot see his lamp in the darkness. That means that most probably his battery is off. Looks like our rover finishes its journey here. So my robot is out of battery, my camera phone is out of battery, my laptop is out of battery, and my drone is also out of 2.5 over 3 batteries. But despite of that, all we did it. We managed to go all that road from the one city here to another there. We managed to make around 1.5 kilometers between two cities by robot almost by itself, almost autonomously. Whew! Amazing. Finally.
I thought the ride will took only 3-4 hours, but in fact it takes 10. But still, we did it. Through mud and blood, through sweat and tears, through night, water and hills, robot did it. Robot did 1.5 kilometers almost by itself, controlled by LLM agent. This is called happiness. While I still have that robot here and have not killed it yet on some muddy or icy place, let me know if you want to see more videos with Earth Rover. Maybe you want to see how it performed the city ride. Oh, that will be very interesting, but will also require a lot of jobs. And I don't really want to do it unless you really want to see it, maybe I should record my own dataset of the robot movement and fine-tune my own first really working open source LLM for controlling a robot. And that's all for today. Thank you for watching the video. And if you're interested how we made an original, much more advanced implementation of LLM agent in RoboCrew for controlling a household robot, I encourage you to check the XL Robot series of videos on my channel. Bye!